Hello everybody and welcome to EduCounts. In this video we are going to keep discovering the features of the quadratic functions in the pure form. In this video we are going to discover the effect of the a value or the coefficient of x squared on the graph if the value of a was a fraction or a whole number. So let's get started and dive in. To discover how a when a is a fraction affect on the graph itself. So let's see that we have the green graph is the original one, which is the pure function f of x is equal x squared, and we can basically notice that the a value here is equal 1 since we don't have any coefficients. So the coefficient is going to be an invisible one or 1. So for the blue graph, its function, or for the function g of x is equal half x squared. So obviously you can notice that the original function, okay, became wider. So this graph looks like we shifted it to the right hand side and to the left hand side like this. We make it wider. One more point you can notice about the graph itself. So if we use any or select any point randomly, like this point, which is 1 and 1 in the original graph, this point became like, or we shifted this point down half a step. So it's going to be the new point on the blue graph would be 1 and half. So instead of 1 and 1, so it's 1 and half. So this is the another effect for the using a as a fraction. But the main role for using a as a fraction is making a vertical shrink, or making the graph wider, in other words. Okay, so let's see what would happen if a, or the coefficient of x squared, or the leading coefficient is a whole number which is higher than 1. Here is an example for the a is higher than 1. So we have the leading coefficient is something's higher than 1. So the original function, which is the green one, where a is equal 1, here is the x squared. And for the blue function, here we have something, or let's say this is for a function, it's called g of x, and it has, like, let's say it's 3x squared. Okay, so this function, its rule is 3x squared. So what happened to the graph, or the green one? So the graph became narrower, okay, like this, as you can see here. And we can simply notice that instead of 1 and 1 on the green, if we select any point randomly, like 1 and 1 here, which is the point that belonged to the original graph, so this point became 1 and 3. So here in the same point here, this point, we already shifted this point up, or vertically, 3 steps like this. So the new point would be 1 and 3, and so on. So this is the original point, 1 and 1. So this point would be 1, 3, and so on. You can notice this. So to sum up, if we have any coefficient, or the leading coefficient was a number that higher than 1, that means that the graph compared to the original one would be narrower. If your leading coefficient, or the value of a, is a fraction, so that means your graph would be wider, and so on. Another point that we need to discover about the, or understand about the quadratic function, which is the rate of change. If you are asked to find the rate of change over a specific interval, so you must be given the boundaries of this interval. Like here, if you look at the graph that we have here, or the given example that we are going to use right now, we have the parabola, and it has two colors. One of them is red, another one is green, and the green looks like the normal one, and the red section is a specific part. So this part is starting from this -1, this point, which is our first boundary, which is the least value, and ends at the point 2. So we can see that how to find the rate of change when x is greater than or equal -1 and less than or equal to. This is the boundary of this interval, which is red section. So to find the rate of change of two values, we need to find the value of each one from the graph. So for example, I need to find firstly f of 2. What would be f of 2 in this case? So f of 2, we have here 2, so you need to go up until you reach this point, which is c. And this point, you can notice that this point is 2 and 4. And this point says that when we use 2 in the function, the output would be 4. So f of 2 would be 4. And for f of -1, this is would be here at the point b. So this point would be 1 and 1, -1 and 1, like this. So, and this point says that If we use -1 in this function, the output would be 1. So right now we have 1. And then what we have to do is just need to subtract them together. So we need to subtract or finding, let's say this point is A and this point is B. To find the rate of change, you need to find f of B minus f of A, like this, over B minus A. It looks like something like the slope of the linear function when we were subtracting y2 minus y1 over x2 minus x1. It looks like something like this. There's a rate of change of a linear graph or a linear function, but the upper one for the rate of change over the curve. So all what we have to do right now just to find the rate of change, just substitute instead of f of b. We are going to use the value of f of b here, which is 4, minus the second value, which is 1, over 2 minus -1. So this is the starting point and the ending point. So this would be 3 over +3, which is equal 1. This is how do you calculate the rate of change over the specific interval on the graph of the quadratic function. Thank you for watching this video. See you in the upcoming one.